Good evening, everyone. I'm Dr. Navneet Kaur from Department of Electronics and Communication Engineering, Sagar Institute of Research and Technology College. Today, I'll be taking lecture of subject Signals and System. The topic of my today's lecture is Classification of Systems. In my previous lectures, I have already discussed about signals and the classification of signals. Now, in this lecture, I'll discuss about the classification of the systems. Now, first, what is system? System is a combination of elements that process one or more signal to accomplish a function and produces some output. System process input signal to produce a desired output signal. Now, suppose if I have a system, if I give input signal to the system and some algorithm or some process act on this input signal, and as a result, we get an output signal. System can be a physical device or it can be an algorithm which performs required operation on a continuous time or maybe a discrete time signal. Now, in this lecture, I'll discuss about discrete time system in which the input is given a discrete signal, say xn, which is also known as input signal or excitation signal. And as a result, after processing through a system, I'll get the output yn, which is called response or output of the system. The processing is done by this system. This system can be a discrete time system or continuous time system, depending upon the type of the input and output signal. Now, notation of any signal. When a signal xn is given to any system, then we write it in the form xn arrow. T is written above this arrow, and as a result, we get yn. That means T is the processing function or transformation operation which operates on xn, and as a result, we get yn. So here, for discrete time, we represent it as xn operating upon the transformation operation, and we get yn. Similarly, for any discrete continuous time system, I can write xt processed by a transformation operation, and as a result, I get yt. A filter is a good example of a system. A signal containing noise is applied to the input of the filter, which act as a system. This filter cancels or attenuates the noise signal. That means it processes the signal. A noise-free signal obtained at the output of the filter will be called as a response of the system. Now, coming to the classification of system. There are 6 types of systems. First is causal and anti-causal system, then linear and non-linear system, time variant and time invariant system, stable and unstable system, static and dynamic system, and invertible and inverse system. Now, first, we'll discuss causal and anti-causal system. A system is said to be causal if the present value of the output signal depends only on the present or past values of the input signal, but it will not depend on the future values of the input signal. So this is an example of a system equation, which is a causal system. Yn, that means the output at present instant n. It depends upon xn, which is the present input, and also on xn minus 1, which is the past input. But it does not depend on the future input. And an anti-causal system is the system in which the present value of the output signal depends only on the future value of the input signal. It may also depend on the present or past values, but it necessarily depends on the future value of the input signal. Here, the future value of the input signal is represented as xn plus 1. So this is the system equation of an anti-causal system. Now, coming to the next type of the system, which is linear and non-linear system. A linear function is a system which follows the superposition principle. Now, let us consider a system in which the transformation operation is denoted as T. Input is xn and output is yn. Now, suppose I have two inputs, x1n and x2n, and these two inputs are given to the same system, and as a result, I'll get y1n and y2n for x1n and x2n respectively. Now, if I multiply these inputs with constants, say a1 and a2, I'll get as an output a1 y1n if I give a1 x1n, and I'll get a2 y2n if I'll give a2 x2n as an input. Similarly, if the combined response of a1 x1n and a2 x2n is given to the system, then I will get the addition of the individual responses also from the system. Here, when a1 x1n and plus a2 x2n is given to a particular system, then the system will give a1 transformation operation on x1n, that is y1n, plus a2 into transformation operation on x2n, which is y2n. That means if I give a1 x1n plus a2 x2n to the system, then a linear system will give a1 y1n plus a2 y2n as a response or output. This property is known as the superposition theorem. And if a system satisfies this superposition theorem, then the system is known as a linear system. Now, we will consider one numerical in which we will understand how to determine whether the system is a linear system or non-linear system. Now, suppose I have been given a system with the equation yn is equal to nxn. Now, I'll consider two inputs x1n and x2n. If I'll give x1n to the system, then I'll get nx1n as an output, say y1n. And if I'll get x2n, if I'll give x2n to the system, then I'll get nx2n as an output y2n. Now, if I'll add these two inputs, say x1n plus x2n, then I'll say that the output will be generated as nx1n plus nx2n. Then the system will act as a linear system. Now I'll explain it in detail. Now, according to this equation, which is a superposition theorem equation, say I have input a1 x1n and a2 x2n. I'll multiply it with a1, x2 with a2. I'll add these two signals and give it to the system. Now, what does the system do? The system will take this as an input, and according to this equation, it will multiply this input with n. Now, if this is the input, the output will be n multiplied by this whole term, which is a1 x1n plus a2 x2n. Similarly, if I'll give my input x1n to the system, I'll get n x1n and I'll multiply it with a1. And if I'll give x2n to the system, I'll get n x2n and I'll multiply it with a2 and I'll add these two. This equation of the output is same as in the previous case when the input given was a1 x1n plus a2 x2n. That means the equation of the system satisfies the superposition theorem. So the system which is given here is a linear system. Now coming to the Next classification, which is time variant or time invariant system. A system is said to be time invariant if its input-output characteristics do not change with time. If it changes with time, then the system is known as time variant system. Now, let us consider a system in which the input xn is given and I'll get output yn. Now, if I delay input xn by k samples, I'll get xn minus k and I'll give it to the system. Say the output is yn comma k. Now, if the output of the system when xn was given to the system is also delayed by k sample, I'll get yn minus k. If this yn minus k is equal to this yn comma k, then I'll say that the system is a time invariant system. That means, in other words, if I delay the input and give it to the system, then I'll get same output, but it will also be delayed by k units. That means there is no change in the output, but only it is delayed by k samples because the input is also delayed by the k samples. So here the input-output characteristics of the system do not change with time. So this system is a time invariant system. So here in steps, I can show that if I delay the input xn by k sample, I'll get xn minus k. I will get the output yn comma k. Now, if I'll give xn, I'll get output yn, and I'll delay yn by k sample, I'll get yn minus k. If these two outputs are equal, then the system is time invariant, otherwise it is time variant. Now I'll understand this concept with the help of an example. Now suppose the system equation is yn xn minus 2. And I have to determine whether the system is time invariant or not. Now I'll take an input xn and I'll delay it by k samples and I'll get xn minus k as an input. Now I give this input to the system, so I get this output. But now here I have input xn minus k. So instead of xn, I'll get xn minus k. So output will be xn minus k minus xn minus k minus 2. So this will be the output. Now, coming to the next system equation, if I'll give xn to the system, I'll get yn. Now, yn will be this. Now, I'll delay yn by k units. So, I'll get yn minus k as wherever it is n, I'll write xn, I'll write n minus k. So, I'll get xn minus k minus xn minus k minus 2. So, this I'll get for a second system equation. Now, I can see here yn comma k is exactly equal to yn minus k. So the system given is time invariant. Now I'll consider another example. Here the system equation is xn plus n xn minus 2. Now, if I delay the input by k samples, I'll get input as xn minus k. So I'll give it to the system. I'll get xn minus k plus n xn minus k minus 2. Now, if I will get output for an input xn, and now I will shift this yn by k units, I'll get, instead of n, I'll get n minus k. So I'll get xn minus k plus n minus k, xn minus k minus 2. Now I can see that these two output equations are not equal. So the system is not time invariant, but it is time variant system. Now next is static or dynamic system. Any system in which output at any instant of time depends on input samples at the same time. That is, it is called static system. Now say this example, yn is equal to 9xn. Here, output at the present input depends on the output at the present instant n depends on the present input. So the system is static system. That means it doesn't have a memory. Now, again, here the output at nth instant depends on the input at nth instant. So it is also a static system. So I can say that the static systems are memoryless system. Whereas in dynamic system, output at any instant of time depends on input sample at the same time as well as at other times also. That means it can depends on the past signals or it can depends on the future signals also. So here we will consider example, output at instant n depends on the present input and also on the past input. So this system is dynamic. Similarly, here output at nth instant depends on the future input and present input. So this system is also a dynamic system. So I can say a dynamic system has a memory. Thank you. This is all for today's lecture.